Hello, I just want to go over Thursday's review with you real quick. Um, so there are 6 questions. The first one is we're going to match up the scatter plot with a calculated correlation. So you don't know exactly what they are, and you're going to have to just go by the extremes. Like this third one is the straightest positive one. So you're going to look for the number closest to 1. And so that is the 0.951. And then this fourth one is the closest to -1. So when we look at this, that's a negative 0.923. And so that's how you just match them up. Between these two, the first one should have the closest number to 0. And then the second one looks slightly negative. So then that's the one left over. And that's how you do that one. Number 2, uh, since 1980, the average mortgage interest rates have fluctuated from a low of under 6% to a high of over 13%. We want to know if there's a relationship between the amount of money people borrow and the interest rate that's offered. So we look at this scatter plot. The first question says, describe the relationship between total mortgages and interest rate. And it looks almost flat, but you can tell it's slightly negative. There's no apparent curve, so you assume that it's linear. So we go back to answer the questions. The relationship is going to be negative, linear, and then weak or moderate. Definitely not strong. And then, of course, do these data provide proof that if the mortgage rates are lowered, people will take out more mortgages? And of course, that answer is always going to be correlation never proves causation. So no. Okay, on number 3, what you want to do for this is you want to put in your stat plot, you want to go in here and put in the position number in L1. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, sticky keys. And then in L2, you're going to put in the distance, 33, 61, 95, 146, 486, 907, 1787, 2801, 3677. Okay, and then what you want to do this, the scatter plot on this, you go to second y equals, I guess we want to quit first. So second y equals, we want to turn the plot on. So enter, and we want the type scatter plot. That's usually the first one there. So that looks good. You can change these if you want, but I'm just ready to graph it. So to zoom stat is 9, so you just type 9, and there's your scatter plot. So you see this, and you want to compare it to what they have here on the choices. And it's the one that looks like it's laying on the x-axis, and it goes up exponentially. So this one. Now the relationship between the position and the distance is nonlinear, and in this case positive, because they're both increasing is why they're positive. You don't have anything decreasing. Okay, and that is the end of that one. The reason you would not do a correlation is because it is not a linear relationship. Okay, number 4. Based on the data collected over several sessions, a statistically minded trainer of office typists modeled a linear relationship between the number of hours of training a typist receives and the typist's speed in words per minute. With the equation, speed, with a hat over it means it is a predicted equation, is equal to 10.1 plus 5.5 times the number of hours training. Okay, so after some training, one of the typists was told that the speed he attained had a residual of 4.4 words per minute. So how do we interpret this? If your residual is positive, that means you are at a higher value than the predicted model. So in other words, if it's a higher value, that means he's typing faster because that's the speed. So he has a higher speed than the model predicted, given the amount of time that he spent training. Okay, we have another prediction equation in this. The amount of potassium is equal to 38 plus 26 times the number of fiber. Okay, so if your cereal provides 10 grams of fiber, how much potassium does the model estimate? So you just plug in 10. So 10 times 26 is 260. 260 plus 38 is 298. So that one you can do even without a calculator. This one, however, you do want your calculator. So here, the price in thousands of dollars is 47.83 plus 0.067 times the size, which is in square feet. So we're talking about homes for sale. This is the model equation, and what does the slope mean? For every additional square foot of the house, the price is predicted to increase by $67. So we found the 67 by multiplying this 0.067 times 1,000 because it's in thousands of dollars. Okay. B says, what price would you predict for a 35 square foot house in the market? So you multiply 3,500 times 0.067 plus the 47.83. And the price you get, you're going to multiply by 1,000. So you just replace the decimal with a comma. Easy enough. I think that's why we do thousands of dollars. Okay, so that should be your answer. And then the third one says a real estate agent shows a potential buyer of 1,300 square foot house. He's saying that the asking price is $5,500 less than one would expect to pay a house this size. So since the residual is less than, that means you find the predicted amount and then subtract it. So you're going to plug in 1,300 into the equation, multiply that by 1,000, whatever you get, and then subtract the 5,500, and you should get the correct answer. And that's it. Okay, so tomorrow is a quiz. Study up, and it is open notes, and good luck, and have a Merry Christmas.